How many stoplights do you drive through in a day? Well, it's all controlled in this cabinet, and we get to go inside and look at everything.
I've always wanted to know what's inside these. It looks like a gaming computer. All these parts to keep cars moving safely through 300,000 intersections here in the United States. And these have to work rain or shine, power or not, and you can never have them mess up and have two greens at the same time. 99% ain't good enough.
So let's open this cabinet door and see everything that makes a traffic signal work. So Steve here's the one with the key who can open the cabinet. You're the traffic light doctor.
Yes, sir. So been working on traffic lights for many years now. When we build them from the ground up as contractors.
Steve Harmon used to work in shipbuilding. He switched to being a traffic signal technician and never looked back.
So you're sitting at a traffic intersection at the middle of the night.
He started posting his job on social media.
Other vehicles around. Well, why is that?
And today he's showing me every part of a stoplight, starting with the power pole where the electricity comes from.
Drop it down to 120 volts, and then you'll see a cable run all the way aerial to this main pole.
The electricity hooks up to the traffic signal the same way it does to your house, with a meter and everything. I bet they get a bill.
And then from there, the underground conduits into this cabinet.
Stephen tells me contractors have a way of boring a trench under the ground without disturbing the pavement on top. You can see the pipe popping through the base of the cabinet.
But the main line of power will come in through these cables here, and then we have some earth grounds to protect the intersection.
Electrically, you need a ground to complete the circuit, but lightning really wants to get down here to the earth. It's going to take the path of least resistance, so if you have a good ground, it'll just zap right through. Have a poor ground, it might start exploring all your electronic equipment, burn it out on its way to the ground.
Hopefully, before it hits anything inside the cabinet or out in the field, it's going to hit the earth ground itself, and it's going to trip a breaker.
Circuit breakers, just like the ones you have in your house, and if something goes wrong, pop, it automatically turns off, protects the wiring in your house. And I can imagine lightning is a huge risk in an intersection. You got a big metal cabinet, you got tall metal poles over there.
It can hit a power pole a mile down the road and travel all the way back.
The big computer case is mounted on the side of the road. It's called the cabinet.
They come from Decatur, Alabama. Usually all the boxes are bolted down. You got to have tools to open them. It's really to keep the honest man out.
These cabinets in Oklahoma have an air conditioner mounted to them, but I imagine that's pretty rare. Gulfport, Mississippi can get stormy.
Heavy rains and winds.
That means power outages, but the stoplights need to keep running.
This is the UPS system, so.
An uninterruptible power supply. Batteries that can run the stoplight when the power cuts out.
He tells me it's car batteries basically in here.
Without ever missing a beat either. It won't go into flash, it won't do anything. It can transfer power with no flicker of the lights or anything.
So the voltage, you have 12, 12, 12, 12, that's 48 volts.
An inverter kicks that up to 120 volts like you'd find in the wall outlet, which he says should keep the intersection running for at least 4 hours. It could run even longer if it goes into that blinking, flashing red mode, because then it doesn't have to power any of the computers inside. By the way, that flasher is just a big version of the blinker unit that cars typically had, which is why it blinks back and forth, back and forth.
So right now it's always activated. It's activated 24/7.
The one in the cabinet's running all the time, so that way if there's a computer glitch, it can just kick right over to the flasher and act like a big stop sign.
There's another one that ran it.
So let's talk red lights and green lights. How does this cabinet know when to switch it? Go back a century ago, cops had to do it by hand. They'd stand next to the traffic signal in the middle of the street sometimes and flip it back and forth. And by the way, that same technology, it's right inside this door. It's still here.
Well, this panel on the front is a police access panel, and it takes a separate key.
Engineers give cops access to the little door here because, bless them, you don't want cops going in the big cabinet there and fooling around with the rest of the electronics.
See an accident or anything happens at a traffic light, they can open this guy up.
If a stoplight is malfunctioning,
They can turn off the signal heads in the field. This switch will just make everything in the field go dark.
or make it go into that blinking red mode.
Put the intersection into flash, and then my favorite, put it in hand mode.
Click a button to make the next street get its green light.
It's kind of like a nurse call button. Gonna start cycling now here. So now it's 6 and 1, which is also the left turn lane.
What's he mean by 6 and 1? Engineers number all the different approaches to the intersection. 1, 2, 3, 4, 5, 6, 7, 8. And these approach numbers help them keep track of who gets what color light as the intersection cycles its way through all of its phases. And each time the cop pushes the button, they move on to the next phase.
So you tell me when it's in this mode, the cops can keep one of the lights green pretty much as long as they want, but there is still a minimum amount of time each light has to be green. So you can't just go click, 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 and have a green, green, green.
On the inside of the cabinet, there's a bunch of switches that traffic signal technicians and engineers to play with.
But this is where a physical person, when you're trying to look into issues, I can push one over and it will lock in a vehicle call for like phase 1.
There's no point going to all the trouble to get a green light if there's nobody waiting for the green light. So to see if there are cars sitting at the red waiting for a green light, you get what engineers call a call.
A computer doesn't want to hold the green light green if nobody's using it, but a car can show up and ask to keep that light green, or ask to change a red light to a green light.
If you're in the hospital and you need that nurse call and you want that nurse to actually come in, you're pressing that button.
But cars can't push buttons, so instead,
Some intersections like this one use a buried loop of copper wire, others use cameras. The one in Mississippi, it uses radar.
these radar plates connect back through the conduit to a box inside the cabinet.
This device here, and it communicates to the controller through this SDLC cable. And they're not used to catch anybody speeding or running the red lights or anything like that.
The technician can hook up a laptop and kind of see what the radar sees. Radar bounces off the cars and leaves sort of a track behind.
We'll have lanes drawn out, and these zones will then be what actually picks up and gives the calls of the vehicles.
Call information is really important for today's traffic signal controllers. And man, have these come a long way from what they were a century ago.
Which side of the intersection gets the green? Well, that comes out of here.
This video is not sponsored by Las Vegas Tourism. Double down on that hotel cost. Watch fast food. Hit the jackpot.
What do you mean a $200 smoking charge? I don't smoke.
In a dwindling city of crowds, going through the motions of having fun, but feeling kind of empty inside. The city of Los Angeles has old traffic signal controllers like these on display, and it shows how far we've come from a century ago when traffic signals were first automated. But every stoplight you use today has a straight-up computer in it.
So the brains of the intersection is going to be this traffic signal controller here.
If the radar is the eyes, or, ears of the intersection, the controller is the mind. It decides every single light bulb, whether it's green or red.
But this shows all the vehicle calls that are happening at the intersection, also showing the timing going down, the amount of time left of the cycle.
And figuring out how long the green light should be for each side of the traffic signal takes a bit of work. Engineers count how many cars arrive at the intersection and how many cars went each way.
1,300 cars a day that come through this approach, we know, and then engineers will calculate an amount of time.
This site you get like 45 seconds, and then that one 15 seconds.
This is all the determined timing that they have at this intersection.
But traffic can fluctuate, even during the same hour.
Those pre-programmed times kind of wiggle a little bit. Yet sometimes more cars show up, sometimes less cars show up. And so we have two new engineer terms here: minimum call and maximum call.
Minimum vehicle recall is a guaranteed length of green light that's going to happen no matter what. But if no additional cars show up, you might as well time it out, throw it back to the other street. Every green light in the world has a minimum time.
We'll see that the minimum green for the turn lanes are 6 seconds.
Set it too short, you end up with something like this.
Oh, that's a short night.
If that counts down all the way to 0, it's going to force that cycle and start going to the next approach. Yellow, 3, 2, 1, and then you got red for 2 seconds, and then it goes to the next approach.
But after that minimum guaranteed green, if cars keep showing up, you extend the light a little bit for each call. Each car adds a couple of seconds so that shot clock doesn't go to 0. But at a certain point, the party ends. You just can't keep adding green time forever, because the other street deserves a chance to go too. So you have to start ignoring the calls. The absolute longest the green light can go with all those extensions is called maximum call. When traffic engineers tie multiple stoplights together, they can do something pretty cool. Coordinate a green wave, or as engineers would call it, signal progression.
If you're on the north side of 49, you should be able to reach the south side of 49 without ever hitting a red light.
But the controllers need to talk to one another, so to do that,
Very white box at the very top of the pole, that is going to connect to more radios all the way up until you reach a cabinet that either has a fiber or a cellular device inside of it.
this newer piece of equipment, called Glance, Lets engineers remote control the cabinet from the main office.
Monitor everything and communicate and connect even to the controller, all the way to every green on every approach. It's
To warn if a bulb has burned out.
going to be tied to majority of the stuff on the backboard.
The traffic signal's sort of central nervous system, where it can watch out for a malfunction.
It's even tied into the fan that's up here and the thermometer there to regulate the temperature and allow an alert if there is an issue, if this cabinet's getting too hot.
But the real magic is how it talks to emergency vehicles.
We'll notice this little puck up here, and this puck is actually able to connect to all those glance units.
Steve has one to test to make sure intersections are working.
So a fire truck would have this same type of device in it?
Almost the same. This one's more of a dumbed down, where I have these dip switches where it's in a fire truck, it's going to be tied to everything inside the cab. So if he puts his left blinker on, it's already connected to that device, and him just doing his blinker would allow that system to pick up. So if he hits that left turn, the next traffic light down will automatically know he's making that left because his blinker's enabled.
He says Mississippi plans to connect the glance unit at this intersection to the nearby railroad. That way, when the arm gates are down because a train's passing,
That blank out sign, that would have a no right turn symbol on it, meaning the people in this right turn lane, they should stop and not even try to get onto the approach.
probably one of the most fascinating pieces of equipment in here is the conflict detector.
So if there's any kind of error with the traffic light,
Like a street showing a green light instead of a red one.
this monitor here is set up to catch that.
And look how nicely the stoplight wires screw into this terminal block. Approach 6, G for green, R for red, Y for yellow. The conflict detector wires straight into it. So if a wire shorts out, it knows directly.
Any sort of issue, it's going to immediately lock up the intersection, put it in flash.
Thankfully, there's a part that prevents big shorts from happening.
This is a household light switch, and you have literally 120 volts come into it. It acts as a gate to turn on or off the garbage disposal or ceiling fan or whatever it is that you want this to turn on and off. And it can handle it because it's got a lot of beef to it. It's a really hardy switch. The switches inside the car for, say, the headlights, they're kind of dainty. They're soft and easy to turn on and off. But the battery has a lot of power it wants to give to run these headlights. And if you ran all that electricity through the switch inside the car, I don't know, it might start smoking or something. So here under the hood, they have something called relays. And here's one of the relays I pulled out of my car. And as you can see, it's got a nice big beefiness to it. It had no problem handling all that electricity the headlights need passing through it. So here's what happens inside the car. The car sends a little bit of electricity to the headlight switch here next to the steering wheel. And that tiny bit of electricity goes back into the engine bay to the relay. The relay sees it as sort of like a remote control function. It goes, oh, I'm getting a little bit of power from that switch inside the car. That must mean you want the headlights on. So clunk, inside here, it turns on the big switch safely from underneath the hood.
The traffic signal does the same thing
Computer runs a little bit of voltage in here.
to a relay switch called the load cell. Just like in your car, the full power goes straight to the relay, or the load cell. A little bit of power goes up to the controller. It chooses a color and sends that little bit of power down to the load cell. And the load cell flips the switch and sends the big power off to the light pole, which feeds into these cables with 8 wires each, down through the conduit and up the pole, which in and of itself takes engineering, because wind blowing in from the Gulf of Mississippi wants to blow the traffic signal down. This video is sponsored by 860 people like you. Thanks for funding over 60% of video production costs last year.
We have to do a 36-inch diameter foundation, and
Building a traffic light pole that won't blow down,
we got to go 15 feet deep in the ground,
it's no easy task.
plus a rebar cage, the anchor bolts, slammer conduits in there as well.
Being so close to the Gulf of Mississippi, Steve tells me the soil is not very good.
It's a lot of sand, and it just kind of erodes in when we hit water, because once we hit like 6 or 8 feet around here, we're usually below sea level, and we start getting running water.
You notice the traffic signal heads up there, they're hanging from a wire instead of a big horizontal metal pole.
And that's not great for this region.
And if 165-mile-an-hour winds hit for a long period of time, all the heads are going to be gone. The poles will stand up, but all the span, everything else will be gone.
He says the stoplights with the horizontal pole hold up a whole lot better. So why in hurricane country do they dangle signal heads from wires? He says here in Mississippi, it just comes down to money.
So maintenance costs over time is a lot more on a span intersection over a mast arm intersection, but getting that upfront money, you're just getting close to $100,000, while a mast arm intersection, you're over $200,000.
It's the same thing I dealt with a year ago. I had a perfectly good old car, but it was starting to cost me a lot of money to kind of maintain it and keep it going. Or I could get a newer car and maintenance would be like almost nothing.
And when money's tight, it's cheaper to just keep driving the old car, even if it costs more in the long run. But that cable doing the heavy lifting is still pretty impressive.
Well, that top cable, it's only a 3/8 strain wire, but it's steel, and it's very durable. I mean, our dump truck left his dump bed open, hit the traffic light, and then kept driving down the road with all the span wire itself, and it started breaking the connectors. But it's a very durable cable.
Yeah, because I was going to say, I mean, I noticed little things like they don't just dangle from the top. They also have to run a wire on the bottom too.
Yeah, that separate wire is going to be a tether wire. It's not really holding a load of any of the lights or anything like that. It's just grabbing that signal head itself so that wind cannot push them all the way up to where you can't see them anymore. You even see like them street name signs, they'll have different brackets where it allows that sign to just flip over and not affect the cables.
All that electricity the cabinet worked really hard to send up there.
And also the cable is going to each of the detection devices.
The radar dishes that are hanging up there.
And then you'll typically jump one cable to another light.
And the wires screw into the back of the signal head.
And it's tied onto a terminal block, and that's connecting each individual LED and each individual LED. So you see how all three of those are green right now. Those are all connected. The greens are connected with each other.
The bulbs, too, have changed quite a bit over the past few decades. Through the 20th century, they'd be incandescent bulbs that used about 100 watts. Today's LEDs only use 15 watts. That cuts power, and the power bill for the bulbs, by 85%. But they cost quite a bit more. But truthfully, everything in this cabinet costs quite a bit of money. There's a reason why you can't run all this stuff off a Raspberry Pi. It needs to work 24 hours a day, 7 days a week, in all kinds of weather. And to do that, you really need something pretty robust. And that's not cheap.
All right, so I have an idea now of what's inside of one of these. So thank you very much, Steve.
Yes, sir. It was a pleasure having you out.
What's your channel?
It is going to be Traffic Light Doctor on YouTube, TikTok, pretty much everything, and then Traffic Light Doctor Steven on Facebook.
He does basically the same video, but more in depth. I'll put a link to it somewhere here. I'll see you next time.
It's my first time seeing the Gulf Coast, and for the winter, it's absolutely beautiful. I understand in the summer and in the fall, it can get a little bit breezy. If this was your first Road Guy Rob video, you might consider hitting subscribe. About once a month, I have big in-depth videos like these made possible by contributors at patreon.com/RoadGuyRob.